Let's look at some practice problems for parallel and perpendicular lines now. This question says line V is defined by y equals 2/3 x plus line. Line W is perpendicular to line V in the xy plane. What is the slope of line W? Okay, so we can see that line V is this equation, y is equal to 2/3 x plus line. So if we want the slope of the line perpendicular to this, we want the opposite reciprocal. So if you take 2/3 x, right? The slope is 2/3. The reciprocal of 2/3, there you go. Our original equation is y is equal to 2/3 x plus 9. The reciprocal of 2/3 is 3/2, right? I just flipped the numerator and denominator, and the opposite sign, well, 2/3 is positive, so I just make it negative. So that's going to be the slope of my line. And now I could use any y-intercept. I'll just do 3, for example, right? And we can see that when I plot them, the graphs intersect and they appear to form a right angle when they intersect. Although, obviously we don't have a protractor or anything to measure it. That's what it does look like, that they form a right angle. So we can say that our slope for the perpendicular line would be negative 3/2. Now, just for fun, let's also find the slope of the lines parallel to this one, right? So we know that for parallel lines, it should be the same slope but different y-intercepts. So if I wanted to, graph a line parallel to this blue one, I can say y is equal to 2/3 x plus 3, for example, right? I just use a different slope, but the same y-intercept, and we can see that the lines appear to be parallel and they never intersect, right? So but again, that wasn't the point of this problem. The point of this problem was that I want the slope of the line perpendicular to this one, and that's just going to be negative 3/2. Okay, let's look at the next question. Line R is defined by 3y plus 12x equals 15. Line N is perpendicular to line R in the xy plane. What is the slope of line N? Okay, so this one is just a little bit more tricky because our equation is written in standard form, so the slope isn't immediately obvious. We need to convert this to slope-intercept form first, and then we can find the slope of the line perpendicular to this one. So 3y plus 12x equals 15. 3y plus 12x equals 15. So I'm going to convert this to slope-intercept form. I'll start off by subtracting both sides by 12x, and I end up with 3y equals negative 12x plus 15. Now I want to get rid of this 3, so I'm going to divide both sides by 3, and I end up with y equals negative 4x plus 5. And if I wanted to find the slope of the line perpendicular to this one, I can take this negative 4 and I'll take the opposite reciprocal of it. So the reciprocal of negative 4, or the reciprocal of 4 is just 1/4, right? And I'm going to make this positive instead of negative because our original one was negative, so I'll make this one positive, right? And that's just going to be the slope of the perpendicular line. If I wanted the slope of the parallel line, I could say just keep the same slope but different y-intercept. So for a parallel line, it could be, for example, y equals negative 4x plus 3. And let's say that I wanted the line that has infinitely many solutions with this one. Well, I could just take this original line, y is equal to negative 4x plus 5, and multiply it on both sides by, let's say, 2. And what I would get is 2y equals negative 8x plus 10. So this line should have infinite solutions with our original line. Again, for perpendicular, we found that the slope was 1/4. I can use any y-intercept for that, so I can say y equals 1/4 x plus 5. That works, or any other y-intercept works. Then this one is parallel because it has the same slope and different y-intercept, and this one has infinitely many solutions. Now let's go back to the problem. We wanted the slope of the line perpendicular, so I'm going to use 1/4. But before we do that, let's quickly graph a couple of our equations, right? We said that the original equation in slope-intercept form was y equals negative 4x plus 5. Now we said that the line perpendicular to this one has a slope of 1/4. and any y-intercept. And we can see that when these two lines intersect, they appear to form a right angle. And the equation parallel to this one we said is y is equal to negative 4x plus 3. So just same slope but different y-intercept. And we can see that they do appear to be parallel and never intersecting. And lastly, we found that an equation that has infinitely many solutions with our original red equation, this red line, could be 2y is equal to negative 8x plus 10. And we can see that when I graphed that one, the red line disappeared. And that's just because this purple line is overlapping with the red line. If I, toggle the purple line, then you can see that the red line shows. And this purple line is just overlapping with the red line, which means that they're intersecting at every single point. So there's infinite solutions. But for our problem, we wanted the perpendicular slope, so that's going to be 1 over 4. Okay? This question says line R is defined by y is equal to 4x plus 8. Line N is perpendicular to line R in the xy plane. What is the slope of line N? So we're just going to take the opposite reciprocal of 4. We can see that the reciprocal of 4 is just 1 over 4, and the opposite sign is going to be negative 1 over 4. So that's going to be our answer.